All right, we are getting close to finishing this chapter, believe it or not. We have one more major skill to learn. It applies here in this section, section 6.3. It also applies in section 6.4. And then you finish with a bang at the end with some word problems. Oh, I shouldn't have given it away. Hey guys, what we're going to do now is talk about what they call complex fractions. Let me get this to draw first. Complex fractions. We need to learn how to simplify these guys. All right, so what is a complex fraction is really the question. Basically up here, it's when the numerator or the denominator contains other fractions in it. This happens, I'll go ahead of the game here a little bit. This happens in later classes if you take them for example, trigonometry. It happens in calculus all the time. And we just want a simple way to clean them up so that we don't have to deal with these crazy fractions. You wouldn't believe how many people forget how to do this as they get into the higher levels, but it's a good skill to have. In arithmetic, we might have seen something weird like this one I'm pointing out to you right here. It's talking about 3/8 plus 5/2, and then you're going to divide by 2/3 minus 1/6. And I go, they're pretty unusual. You might have a plan already from arithmetic in the past. I think what most people tend to do is they remember something about, well, if I add the numerators, let's pick another color. If I add the numerators and the denominators together, I get a fraction over a fraction. And then someone might have said, when I divide with the second fraction, my teacher told me, invert and multiply. Or another teacher might say, multiply by the reciprocal. So what that means is, if you're going to divide by 3/6, remember, flip it over, multiply by 6/3, and then the rest is just doing your thing, canceling and reducing to get your answer. All right. We don't really do things that way with polynomials. You could do that. But I think the fastest way to handle this, and this is a real, you're going to look at this example and it might make your eyes cross or whatever, but what I'm showing you is there's another way to do it, and that is, here I have my first example, and then we're going to do two more, but this one's written out in nice penmanship and all this stuff. It's 2 over x plus x over x plus 1. Downstairs is 3 minus 5 over x plus 1. So I rewrite it, there it is. And look what I'm doing. Look what we have to do in this case. Get another color going on. We're going to multiply top and bottom by the same thing. When I multiply top and bottom, that's how you're converting fractions. Remember, if you had like 2/3 and you wanted to multiply top and bottom by 4, you could. When you multiply top and bottom by 4, did you know that you're just multiplying by 1? Well, the same thing is happening here. That's just a glorified 1. But it has this magic of, watch what I do here. Let me erase this guy. Okay. Watch what I do here. I'm going to distribute it with each fraction. Distribute. Here it is. It's going to multiply with 2 over x. It's going to multiply with 3. It's going to multiply with x over x plus 1. And it's going to multiply with 5 over x plus 1. Yeah, I'm not showing this to you guys. I'm going to do it right now. I'm going to do this in red. What happens is, when you do this multiplication, okay, they go right next to every fraction, even if it's not a fraction, and they cancel. That x cancels. This x plus 1 cancels. Nothing cancels here, but you still have to do it. And then finally, the x plus 1s cancel. The survivors then are who? Let's see. We've got in the next step, let's see. Oh, it's 2 times x plus 1, there he is. X times x, there he is. 3 times all those guys, there they are. And then finally, 5 times x. Do you see that? There he is. The rest of this is multiplying together, basically gathering your like terms and seeing if you could possibly FCR. But in this case, it didn't happen. The answer is this guy right there. So this is a method, and that's a mess that I wrote there. So we're going to do another example down below here. But basically, I have some sort of process here. You factor all the denominators. You play even Steven to figure out what we call the least common multiple, or LCM, of all the denominators. Here's the thing. Multiply top and bottom with the LCM. This is legal. And what it does is it cancels the denominator. Some people call this clearing fractions. Clear the fractions. Okay? And we're going to do two examples, like I said. Once you do that, you're going to be able to cancel all the denominators, all the common factors that you see. Then you're going to multiply and simplify, and then check FCR. So you ready to give it a try? Let's try this thing. It says simplify in this case. Here you are doing your homework. You've got this problem. X over 3 minus 3 over x over 3 minus 2 plus 3 over x. Here, the first thing you want to do is factor the denominator. Well, there's not much factoring to be done. The second part is to so-called play even Steven with these guys. So pretend you were going to play even Steven with it. You could do something like, well, gee, this guy over here has an x. Wouldn't it be nice if I had an x? So I'm going to give myself an x top and bottom. Okay. This guy wants a 3. Okay, give him a 3. But you're going to play it for all the denominators. Okay. So the next step would be, oh, he needs an x. This guy needs a 3, this 3. This guy doesn't, he needs both. He needs 3 and x, so 3x and 3x. Now that's a weird way to do it, but really what that does is it tells you, you know what? 3x seems to be the winner, okay? 3x seems to be the denominator. So if you don't mind, I'm going to rewrite this and go, it's x over 3 minus 3 over x. I'm hoping to draw your attention to the fact x over 3 minus 2 plus 3 over x, to the fact that, you know, another way to look at this instead of playing even Steven is, what if we just play like I want to kill off all the denominators? That's another way to look at it. Like in this case here, if I multiplied him by with a 3, that would cancel. But if you're going to do it there, you got to do it everywhere. Okay, so I'm starting to talk a different way about this. Like, okay, this guy gets a 3 also. This guy gets it. Why am I multiplying everywhere? Okay, that means I have to look at it a different way. Okay, I forgot one more. This guy too. So that gets confusing. So maybe I should just simply say it this way. Okay, the way math textbooks always do. See, what we're trying to do is, one, figure out what I need to do, what I need to multiply by, and then, watch this, multiply by it. In fact, I can say 3x, but that confuses some people. It's easier maybe for people to see 3x over 1. Think of that as distributing, 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 distributing. I'm going to rewrite it again. Okay, it's equal to x, same thing, x over 3, 3 over x over 3 minus 2. I'm going to leave some space, plus 3 over x. And this is going to help you see the mechanics. 3x over 1 hits here, and here, and here, and here, and here. See, because of the distributed right there. Okay, watch what happens. Might need another color. Let's go green to cancel stuff. Okay, so the 3 cancels and leaves us with, see it? X times x, or x squared. Next one, minus. X's cancel, leaves us with 3 times 3. How about 9? Over. 3's cancel, leaves us again with x times x, x squared, love it. This one here, nothing cancels, so minus what? 6x, and then lastly, x's cancel. What do we have here? Plus 9. All right. We simplified a complex fraction. That's it. You have to figure out what you're going to multiply by and then multiply everybody by it. And when you do that, you get to cancel a whole bunch of fractions. Are we done? No. I'm suspicious. I'll check with FCR. Thank you very much. We're going to take this guy and factor. Yep, it's a difference of squares. And downstairs factor. Yep, guess what? It's a perfect square trinomial. So we're getting x plus 3, x minus 3, x minus 3, x minus 3. I did that fast. I didn't know that was going to happen. Cancel, baby. F, C, and rewrite. Answer is x plus 3 over x minus 3. Now that thing where you reduce it like that is an old story by now, hopefully, and you've studied it a lot. But this new thing of canceling the fractions by multiplying by the least common multiple is used here with complex fractions, which to you guys are kind of maybe unusual. But next section, when we're solving equations, you do it there. You clear fractions. We've done it before with numbers. We're going to do it with rational expressions as well. One more for fun. This is a lot like maybe one of your show your works. Let me write it bigger. We're going to simplify 3x plus 1 all over x minus 1 and over, see how complicated it is? 1 plus 2x over x plus 1. Okay, we are going to figure out what we need to multiply by to make things cancel. Take a quick look at this, or a long look if you want. See this denominator here? I need to cancel him. So everybody, here's the mistake students make in beginning algebra. They go, okay, x minus 1 there. This guy needs an x plus 1, so I'll put, you know, you're messing up with the rules of the game. You can't multiply with the different things top and bottom. It has to be whatever you do upstairs, you do downstairs, okay? This is the same one whole problem. They're tied together like that. But you know how you get out of that trap? Why don't you multiply with both? It's the only way to do it, okay? That's the only way to do it. So we are going to do that. We're going to take this guy. There's only one fraction. He's going to multiply there. We're going to take this guy. He's going to multiply there. But guess what? That little one, people tend to forget him, but he multiplies there as well. So here we go. You ready? Oh, yeah, let's write it that way again. 3x plus 1 over x minus 1. 1 plus 2x over x plus 1, okay? And I'm going to put this in red, actually. I'm going to multiply this guy with x minus 1, x plus 1. It's painful at first, x minus 1, x plus 1, and then here. But it saves you so much wear and tear down the line. If you can master this one move, you've got it. Because you get to cancel now. Cancel, cancel. Why? Because you came in with the LCD. Cancel, cancel. Are you kidding me? Yep, that's how it goes. So who survives upstairs? This guy times this guy. See it? So we're going to have 3x plus 1 times x plus 1. Downstairs we have 2x times that guy. So 2x times x minus 1. Does anything cancel there? I don't think so. You know what? We're done. That's it. We've gone from a double-decker nightmare, so to speak, to one that's, it's still not pretty, but at least there's no fractions inside fractions. And that's it for this video. Rewind and look at it again. It's a matter of just finding that LCD, or LCM, multiplying top and bottom by it, and making those fractions disappear. Thank you.